Okay, let's jump right in. Welcome to this explainer. Today, we are looking at some truly fascinating research that takes AI from being just a, passive chatbot and turns it into an active master detective for massive industrial data sets. We're talking about a system called TADI, which stands for Tool Augmented Drilling Intelligence. Seriously, if you've ever wondered how artificial intelligence is graduating from just writing emails to actually solving complex multi-million-dollar engineering problems in the real world, well, you are definitely in the right place.
Here's the game plan for today's investigation. We'll start with Section 1, the messy data. Then 2, meet the detective. 3, the detective's toolkit. 4, solving the case. And wrap up with 5, the big takeaway.
All right, Section 1, the messy data, aka the scene of the crime. To really understand why we need this AI detective in the first place, we've got to look at the absolute mountain of evidence left behind on a typical offshore oil rig. To put that scale into perspective, just think about this number, 40,000 files. In the Equinor Oilfield dataset alone, which is the public dataset this research focuses on, there are roughly 40,000 distinct files. We are talking about nearly 3 decades of drilling campaigns, spanning 26 different wellbore sections, drilled between 1993 and 2016. It's an overwhelming flood of information. If a human drilling engineer wanted to review just a single 60-day well operation, they'd have to manually read through 60 separate daily reports, cross-reference them with massive volumes of sensor telemetry, and basically try to piece the whole story together entirely by hand. Now, the real headache here is the clash between two completely different types of data. On one side, you have structured data. This is your high-frequency sensor readings, true vertical depth, hole diameter, fluid density, rotation speeds, you name it. It's super clean, organized, and vast, but it completely lacks context. On the flip side, you have the unstructured data. These are the daily drilling reports, or DDRs. These are messy, free text narratives typed out by human engineers right there on the rig. They hold all the Y's in the house, but good luck trying to query that in a spreadsheet. Existing dashboards simply cannot cross-reference these two completely isolated worlds. That brings us to Section 2, Meet the Detective, Agentic AI. To bridge this huge gap between cold sensor numbers and messy human stories, the researchers needed a totally new approach. Enter TADI. That approach is Agentic AI. Unlike your standard passive AI that just sits there and summarizes whatever text you feed it, an Agentic AI acts as an autonomous investigator. It doesn't just wait around. It actively hunts for clues. It plans out its own investigation, picks its own tools, navigates completely different data sources on its own, and ultimately formulates structured, evidence-backed answers. It's a real game changer. TADI essentially combines 3 distinct skills that most platforms traditionally keep totally isolated. Number 1, it can write and execute SQL queries to interrogate that structured data. Number 2, it performs semantic text searches, so it can actually read and comprehend those unstructured human narratives. And number 3, it uses multi-step reasoning to orchestrate the entire operation. It seamlessly blends hard database analytics with reading comprehension, acting as the intelligent brain that finally connects the dots. Moving on to Section 3, the detective's toolkit, the dual-store brain. To actually pull off this massive investigation, TADI separates its memory into 2 distinct areas. You can think of this kind of like the left and right hemispheres of our AI detective's brain. DuckTB handles the structured sensor math, containing 12 tables and over 65,000 rows, all queried via SQL analytics. Meanwhile, over on the other side, ChromaDB handles the unstructured text, utilizing semantic similarity search across more than 36,000 embedded human-written documents. When you throw a complex engineering question at TADI, it knows exactly which side of its brain to tap into to find the right clues. But just having the databases isn't enough. The AI needs a method. TADI's orchestrator actually loops through these 3 steps up to 10 times for a single complex query. First, it observes the question and plans out which tool it needs. Second, it executes that specific tool against the database. And third, it synthesizes the new evidence it just found and decides its very next move. TADI figures out its next search path based entirely on the clues it just uncovered. It's literally exactly like a human investigator following a paper trail. So, what exactly are these tools? Well, instead of trying to teach a generic language model the entire field of petroleum engineering from scratch, which, let's be honest, would be a nightmare, the researchers gave it a Swiss Army knife of 12 highly specialized deterministic tools. These tools encode about 2,800 lines of complex drilling engineering logic. TADI doesn't have to invent a mathematical formula for classifying non-productive time. It just has to know exactly when to pull that specific, pre-built tool out of its kit to extract the answer. Let's see this in practice. Section 4, Solving the Case, TADI in Action. Here's a real-world case study from the Oilfield, where engineers asked TADI to diagnose an operational issue on well 15-9 F-11T2. The AI immediately springs into action. First, using its structured database tools, TADI starts crunching the operational metrics. It very quickly discovers that the rate of penetration, which is basically the drilling speed, had severely dropped to just 14.4 meters per hour on specific days. That is a massive drop compared to the well's average of over 22 meters per hour. So, it found the anomaly in the structured telemetry. But why did it drop? Sensor numbers alone just can't tell us that. Instantly, TADI pivots. It fires up its semantic search tool and dives into the unstructured side of its memory. And boom! It pulls this exact quote from the Daily Drilling Report on March 25, 2013. The human engineers noted that the crown block fastline sheave bearings had failed. This was a major mechanical issue that forced them to pull out of the hole. TADI perfectly diagnosed the mechanical failure by matching the speed drop in the sensors with the precise narrative quote from the guys right there on the rig. And this is absolutely crucial. Because of this process, TADI achieves a perfect evidence grounding score, or EGS. See, the system is built with a strict prompt structure that forces it to cite its sources. It literally cannot hallucinate. Just like a real detective going to trial, it has to provide both the physical forensics, the exact numeric sensor measurements, and the signed witness statement, that direct quote from the daily logs, to officially close the case. Finally, Section 5, the big takeaway, broader impacts. So, what does this all mean for the future of how we analyze complex industrial operations? The most fascinating takeaway from this entire paper is that a clever framework of specialized tools and strict prompting rules is vastly superior to just throwing a massive, generic AI model at a problem. You really don't need a trillion-parameter language model to solve industrial engineering issues. What you actually need is an intelligent orchestrator equipped with domain-specialized tools and a rigid programmatic demand for verifiable evidence. And the implications here stretch way, way beyond offshore drilling. Any industry that pairs rigid sensor data with messy human logs is about to experience a massive paradigm shift. Think about subsea infrastructure inspection, where you have thousands of hours of sensor telemetry mixed with written dive logs, or aviation maintenance, where complex engine data sits right alongside handwritten mechanic notes. Even clinical trial monitoring relies on this exact same mix of hard physiological vitals and a doctor's narrative notes. So I'll leave you with this thought to ponder. We've seen how a dual-store brain and specialized tools can successfully tame decades of completely chaotic, disjointed data. If agentic AI can conquer the chaos of an offshore oil rig, what messy industry will it transform next? The era of the AI detective is just beginning. Thanks for joining me on this explainer, and keep questioning how the massive amounts of data all around us are being interpreted.